There are several types of chemical bonds. We're going to discuss two of them in this class. Ionic bonds are one major type. Another major type are covalent bonds. We're going to focus in now on ionic bonds. An ionic bond is a chemical bond formed from the attraction of large numbers of cations and anions. And these are Coulombic attractions between positively charged particles and negatively charged particles. Let's review some terminology. What is a cation? That is a positive ion. How did the ion become positive? It lost electrons, correct? It lost some negative bits. What then is an anion? This would be a negative ion. How did an atom become negatively charged overall? Well, it must have gained some electrons, gained some negative bits. Well, I think you can imagine what's going to happen if we get cations and anions close together. They are going to attract each other. Positive and negative attract. That's a Coulombic electrostatic attraction. And that attractive force is known as an ionic bond. It is our first type of chemical bond. It's a strong chemical bond. One way of thinking about this is that the formation of ionic bonds involves the transfer of electrons and the formation of ions. Let's imagine, as you can see in my diagram down here, that a sodium atom and a chlorine atom come near each other. You can see in this energy level diagram that sodium has one valence electron. You can see in this diagram that chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. You guys already know what's going to happen. Sodium would really like to lose that one valence electron, and chlorine would really like to gain an extra valence electron. So if sodium and chlorine find themselves close together, you can think about it like this. Sodium will give away his electron to chlorine, and chlorine will gladly take it. Now both atoms have reached an octet. They both have achieved an octet, and they've both reached a potential energy minimum. They are both stable now. So by working together, by transferring an electron, they are stable. But what have they formed? Well, you know that when sodium loses its one valence electron, it is now positively charged. It is a cation. When chlorine gains that extra electron, it is now negatively charged. It's an anion. What happens when you have positively charged substances next to negatively charged substances? Yes, indeed, they will attract each other. And that attractive force is going to be quite strong. It is an ionic bond. So that is how ionic bonds form, and they are bonds, attractive forces, Coulombic electrostatic attractive forces between cations and anions. And how do cations and anions form in the first place? They form from the loss and the gain, aka the transfer of an electron. Typically, ionic bonds will occur between not just a single ion, a single cation, and a single anion, but between large numbers. A lot of this will be going on. Very, very rarely, pretty much never in nature, would you find a single sodium atom transferring its electron and then bonding to a single chlorine atom. That's not what happens. Instead, usually it's large numbers. And here's an important thing to note, which you should have already realized. Metals are always going to become the cations. Nonmetals are always going to become the anions. Sodium is a metal. It's on the left side of the periodic table. Chlorine is a nonmetal. It's on the right side of the periodic table. So that's another rule to recognize ionic substances, ionic bonds forming ionic compounds. It's going to be between metals on the left side of the periodic table and nonmetals on the right side. Once again, this will never happen between a single, say, sodium ion and a single chloride ion. Instead, it always occurs between large numbers of these. And when you get large numbers of ions all attracted together, it will always form this interesting structure known as a crystal lattice. I put the word large here. That's large in chemistry perspectives. By large, I don't mean like a big boulder sitting out in nature, although rocks are ionic substances for the most part. I mean large as in more than just a single sodium and single chlorine. What is a crystal? A crystal is defined as organized, as something that has an organized and repeating geometric pattern. The vertices, aka the corners, the points of the crystal, are the cations and the anions held together via ionic bonds. So let me show you a picture of what I'm talking about. This would represent a sodium chloride, NaCl. This right here is, by the way, is called a chemical formula. We'll talk about how that works in a bit. The small purple spheres, those would be sodium ions. The big green spheres here would be chloride ions. And you can see that this compound, it's not just a single chlorine and a single sodium. It's many of them. And notice how it's an organized, repeating geometric pattern. This is a crystal lattice. What is keeping this together? Coulombic electrostatic attractions, ionic bonds. The positive ions are attracted to the negative ions, and vice versa, all throughout this structure. So you can see that the ionic bonds here, which I'm kind of representing with red, is what is holding this crystal together. And you can see that, once again, it's more than just a single sodium and a single chlorine, but is many, many, many of them. This is a crystal lattice. Ionic compounds always form these large crystal structures. Let's talk about chemical formula real quick. A chemical formula is a way of using the chemical symbol of elements to show how elements combine to form chemical compounds. For example, sodium and chlorine. You know that sodium will lose a valence electron to form a 1+ cation. Chlorine will gain an electron to form a 1- anion. When those come together to form the large crystal lattice, we would say that structure is called sodium chloride. This would be the chemical formula right here. The thing to note about chemical formula is that they always show something about the number of atoms in the structure. There's a little invisible 1 right here and a little invisible 1 right here. Those are called subscripts. I say invisible because we do not typically write the 1. It's just implied that there's a 1 there, 1 sodium, 1 chlorine. But here's what you need to know about formula for ionic compounds. This formula is not saying that there is actually 1 sodium atom and 1 chlorine atom in my crystal lattice, in my compound. Instead, for ionic compounds, this is only true for ionic compounds. We will see something else for covalent compounds. For ionic compounds, the fact that there is a 1 and a 1, that shows me the simplest ratio of ions in the crystal. In other words, if I were to go through here and count up every single sodium atom or ion and every single chlorine ion and find a ratio between them, I would get a 1-to-1 ratio. For every 1 sodium, I would find 1 chlorine. That's the simplest ratio, 1-to-1. 1 sodium for every 1 chlorine, that's a ratio. Therefore, my formula would be sodium 1, chlorine 1. We never ever write the 1, sodium chloride. Now, why does that make sense? It is because ionic substances like to have neutral, balanced overall charges. So ions will join in the simplest ratio to cancel out their charge. Let's go back to this example. We know that sodium forms a 1+ cation. Chlorine forms a 1- anion. Well, what's the simplest ratio here to get an overall charge of 0 for them to cancel out their charge? How can they combine with each other to cancel out the charge and get an overall charge of 0? Simple enough, right? There needs to be 1 sodium for every 1 chlorine, NaCl. That would be the compound, the formula for this compound, and again showing the simplest ratio. We can figure that out because sodium has a 1+ charge, chlorine has a 1- charge. It would cancel out. Let's do some examples of some other substances. Write the formula for the chemical compound formed between calcium and fluorine. Well, first of all, we would need to determine if this is even an ionic substance. calcium and fluorine. Would calcium and fluorine form an ionic compound? They would, and I know that because calcium is right here on the left side of the table. Fluorine is on the right side. Calcium is a metal. Metals are on the left side. Fluorine is a nonmetal. Nonmetals are on the right side. Calcium and fluorine, metal and nonmetal, I know they're going to bond together with an ionic bond. So let's see if I can figure out the formula. Remember, the formula for an ionic substance shows the ratio in which these atoms or ions would join together in a crystal lattice. And they join together to cancel out their charges, right? So I need to figure out something about the charge. What type of ion do these form? You can see why the skill from last time is very important, and it's coming back to haunt us right now. I need to figure out what charge these make when they develop ions. Calcium is right here with 2 valence electrons. What kind of charge is it going to have? That's correct. It's going to have a 2+ charge, Ca2+. How do I know that? It has 2 valence electrons. It's going to lose those to become like argon. I could also just count over 1, 2 to argon. So calcium will lose 2 electrons and become 2+, a 2+ cation. Fluorine is quite simple. It just needs to gain 1 to become like neon. If it gains a negatively charged particle, an electron, it's going to have an overall negative charge. So these are my ions that are going to form in a crystal lattice. So what would the formula be? Remember, they're going to join together in the simplest ratio to cancel out their charges. So if this is 2+ and this is 1-, what's the ratio going to be? Yeah, very simple. It's going to be a 1 to 2 ratio. It's going to take 2 of these to cancel out the charge of 1 of these. Therefore, my formula would be CaF2. Here's another way of doing it, and this is sometimes known as the crossing over method. You take the charge of the ions, 2, and that represents a 1, and you just cross them down. And that will become the subscripts, Ca1F2, CaF2. Simple enough. Write the formula for the chemical compound formed between lithium and chlorine. Let me go back to my periodic table. Lithium is right here. It's a metal. Chlorine is right here. It's a nonmetal. So I know it's going to be ionic. What charge does lithium make? It's in group 1. Anything in group 1, as you know, will form a 1+ cation. Chlorine is right here. It just needs to gain 1 electron. So it's going to form a 1- anion. This is quite simple. 1+, 1-, what's the ratio going to be? 1 to 1. LiCl would be the chemical formula. By the way, we always write the metal, the positively charged cation, we always write it first, LiCl. How about this one? The chemical compound formed between aluminum and oxygen. Let me find aluminum. Aluminum is right here. Is it a metal? It is a metal. Even though it is on the right side of the table, it is to the left of my metalloid stair step. So it is still a metal. And oxygen is right here, a nonmetal. Metal and nonmetal, I know they're going to form an ionic compound. So what charges will they form? Aluminum, this one is tricky sometimes. It has 3 valence electrons. So what's it going to do with those? Is it going to gain 5 and be like argon? No, it's going to lose 1, 2, 3 and become like neon. So if aluminum loses 3, it's always going to be 3+. Hopefully you're recognizing this pattern. All of our metals are going to lose valence electrons to become positively charged cations. That is what makes a metal, by the way, chemically speaking. How about oxygen, this nonmetal? It's going to gain 2, 1, 2, to become like neon. So O2-. So this is a little bit tricky to think about, but what ratio will these ions form in the crystal lattice to have a neutral canceled out charge? How can they cancel out their charges? The answer is going to be, I need 2 aluminum ions for every 3 oxygen ions. Is there a really simple way of figuring that out? Yes, there is. Just use the crossing over method. Bring the 3 down here. That becomes the subscript for oxygen. Bring the 2 down here. That becomes the subscript for aluminum. Al2O3 would be the chemical formula.